solve inequalities algebraically and graphically. Example 1, the absolute value of x minus 4 is less than 8. Absolute values always have more than one answer. They usually have two. We need to set this up by showing that we can have two different answers. We have x minus 4 is less than 8. And then what you need to do is take this sign and slide it over here, and then put the opposite of 8. And now we are set up to complete the absolute value problem. I'm focused here on this compound inequality. I see that x is being subtracted by 4. I'm going to add 4 to the right, to the left, show my cancellation, and I have x is less than 12, and x is greater than negative 4. We would say that x is greater than negative 4 and less than 12. Interval notation, it is greater than negative 4. It doesn't include negative 4, and it's less than 12. It doesn't include 12. There is interval notation. We can also see this on the graphing calculator. We can go to y equals, and we're going to graph two sides of the equation. We're going to graph the absolute value of x minus 4, and then we're going to graph 8. y1 will equal the absolute value of x minus 4, and y2 will be 8. Under math, numbers, and there it is, absolute value. So we have the absolute value of x minus 4, there's y1, get out of the absolute value, go down to y2, we're going to put 8. Graph. My graph is messed up, so I'm going to go to zoom. Number 6 is a standard 10 by 10. I'm going to start from here to see if I can see everything that I need, and I can't see everything that I need. And what I want to do is I want to shift the graph over so that I can see the right-hand side more, and I don't need to see all of the minimums on the y value. Window. My x minimum is set at negative 10. I want to reset my maximum. Let's go with 20 and see if that's big enough. I don't need to be all the way down at negative 10, so let's say negative 5, and my y max could stand to go up a little bit, so I'll say 20 on that as well. Let's see what the graph looks like. All right, that's better. I would like to look at these intersections. What are these intersections? I am going to calculate in blue. And we want to look at the intersect, number 5. Number 5, intersect. I'm just going to hit 5. And now it's asking me for my first curve. My first curve is the absolute value of x minus 4. I'd like to be over where the intersect is. You want to be right there. This is where it's intersecting. The first curve is the absolute value, enter. The second curve, is it y equals 8? And that is true, so I hit enter again. Hit enter again. The intersection is at negative 4, y is 8. Negative 4, x equals negative 4. We need to do it one more time. We go back to calculate in blue. We want to calculate something about this graph. Number 5, and this time we need to go over to the right. There's my intersection. First curve, is it the absolute value? Yes, enter. Second curve, is it y equals 8? Yes, enter. It says the intersection is at x equals 12. Y equals 8. We can see here from our answers that algebraically, we came up with the same answers, -4 and 12, -4 and 12. What does this mean for the picture of the absolute value? It can't be just -4 and 12. This is an inequality. It's saying, what is the absolute value less than 8? I'm going to draw the graph up here. All right, here's the graph. We have the absolute value, and then we have y equals 8. This says, what is the absolute value less than 8? Well, this is where it would be less than 8. Where is the absolute value less than 8? From -4 to 12. This is where it is less than 8. Graphically, we can see where it's less than 8 when it's between -4 and 12. The absolute value of 3x minus 2 is greater than or equal to 5. We'll start by setting up the absolute value that has two answers. That would be 3x minus 2 is greater than or equal to 5, and I slide that sign over and it becomes less than or equal to the opposite of 5. And now I solve my two-step inequality. Divide by 3. Interval notation says that x is less than or equal to -1 and greater than or equal to 7/3. We are less than -1, there's less than, and then greater than 7/3. This interval needs to be written in two sections. I can't just write it in one section. It's not going in the same direction. The interval notation would say that -infinity to -1. -infinity to -1. It doesn't include -infinity, but it does include -1. Then you use this symbol to show that it's in union with something else. In union, it's like saying and. In union, we are going from 7/3 to positive infinity. 7/3 it includes, and positive infinity it does not. That would be a final algebraic answer for this problem. I needed to look at the graph so I could better understand what the interval notation was. There's the algebraic. Now, graphically, we're going to do the same thing that we did last time. We're going to go in and we are going to clear out what we have in there. All right. The absolute value of 3x minus 2. Math. Go to math. Go over to numbers. There's the absolute value of 3x minus 2. And then we're going to have that y equals 5 and graph. I'm going to set my graph back to the standard zoom number 6. All right. We're going to do an intersection of the first side. We are looking for the intersection. We're going to calculate. So we go to second, calculate, second, calculate, number 5. We're going to go up to where it's intersecting. The first curve is the absolute value, yes. And the second curve is y equals 5, yes. Okay. The intersection is at x equals -1. All right, so we have y1 was the absolute value of 3x minus 2. Y2 was 5. There's negative 1, 5. And now we're going to calculate the other side. Calculate, second, calculate number 5, go over to the other intersection. Okay, absolute value is the first curve, enter. Y equals 5 is the second curve, enter, enter again. The intersection is at 2.3 repeating. 2.3 repeating. Is 2.3 repeating the same thing as 7/3? All right, so we know that the intersection was at 7/3, 2/3, 5, and my vertex is at 2/3. Solve for this and can see that it's at 2/3 right here. Draw my absolute value. Draw my y equals 5 line. And now I'm going to answer the question. The question says, when is the absolute value greater than or equal to 5? When is it greater than or equal to 5? It would be greater than or equal here and greater. Equal here and greater. This time, we're looking at an infinite solution. It does include these places, and it goes to infinity. It's going out, 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 out to infinity. That is where the absolute value is greater than or equal to 5. It has an infinite solution, whereas the first one, when it was asking that it was less than, it was finite. It was only in between -4 and 12. All right. Example 3 says to solve. We've been using the quadratic formula, but to move forward in pre-calculus, we need to learn to be really good at factoring. Factoring is a big part of what we do when we do it algebraically. We are looking to factor x squared minus x minus 12. We're going to use 2 sets of parentheses. The first term, something times something equals x squared. What times what equals x squared? X times x equals x squared. All right, now the second part of this is I'm looking for a factor of 12. What are the factors of 12 that we have? 12 can be 1 and 12, 2 and 6, 3 and 4, 1, 2, 3, and I'm back on the other side, 4, 5. So these are all the factors of 12. I'm looking for factors of 12. Once I have my factors, now I'm looking to see when it's going to be added together to equal -1. When I say add, I'm talking about integers. It could be positive and negative numbers. Which one of these factors could I add or subtract to -1? That would have to be -4 and +3. -4 and +3 add to -1, and we have -12 here. It also multiplies to -12. Multiplies to -12, and it adds to -1. That would be +3 and -4. If you're wanting to check your work, you would simply put it back together. X squared. Your inner and your outer are your middle term. 3 times x is 3x. X times -4 is -4x. And that adds to -1x. So we have x squared minus x, and 3 times -4 is -12, which is what we started with. So you can always check your answer by multiplying it back together. we're going to solve this, and we're just going to switch it to an equal sign. X equals -3, x equals 4. Okay, this is an inequality, so we need to check our picture to see what's going on. When is the parabola greater than 0? We have x squared, x, here's your square button, squared, x squared minus x minus 12 in graph. All right, I want to see how far this is going down. I'm going to fix my y minimum window. I'd like my y minimum to go to, let's start with -20 and see if that helps. All right. So I can see my parabola here, trace, just curious how low this is going down. Y is about -12. All right. All right, let's see. Here is where you're going through here, we're going through here, and we're offset just a little bit on here. So it's coming down. All right, we've sketched our parabola. We have our solutions of -3 and 4. We're ready to answer the question. The question says, where is the parabola greater than 0? Here's my parabola. Where is it greater to 0? That is y equals 0. Y equals 0 is right here. When is the parabola greater than 0? Is it greater than 0 down here? Or is it greater than 0 up here? It is greater than 0 on top. This would be where it's y is greater than 0. This is the answer, and we need to write our final answer. This is going out to infinity, so that would be -infinity to -3. It does not include -infinity. Does it include -3? No, it's just greater than that. So that would be not including that in union with, now we're going from 4 to positive infinity. It does not include 4, and it's going to positive infinity. That is your final answer. The book does not show how to do this algebraically, except for factoring. There is a way to figure this out without looking at the graph. Why don't we try that on the next example? I can use the graphing calculator to help me figure out my final answer, but I can also do that algebraically. Example 4, solve. So we want to factor. We have 2x squared plus 3x. We have factoring that can be done in this form. Here, there's 3 terms. I don't have 3 terms on this. What am I going to do? Yes, I'm going to take my 20 and put it on the other side. That would be 2x squared plus 3x minus 20. I did not multiply or divide. I used subtraction to put it on the other side, so I leave my sign the same, and I have 0. All right. Now I can try factoring. 2 sets of parentheses. What times what equals 2x squared? That would be 2x times x equals 2x squared. Now factors of 20 that are going to add to 3. Factors of 20, 1 and 20, 2 and 10, 3, 4, 5, 6, 7. We're back on the other side. That's all we have. Factors of 20, they're going to add to 3. I do not see any factors that are going to add to 3. 4 and 5 could be 9 or 1, 12 or 8, and 21 or 19. We do not have any factors. That's what it looks like, right? It looks like we don't have anything like the previous problem. That's going to add to 3, but we forgot about this number out front. This is going to affect our number crunching. I'm going to switch to a pencil, and I'm going to do my guesswork. I'm going to start with, I'll start with 2 and 10. 2 and 10. I'm looking at the inner and the outer to see a number for the middle term. 2 times x is 2x. 2x times 10 is 20x. Can I ever get 20 and 2 to add to 3? No. Before I get rid of those numbers, I would switch them. The 10 over here and the 2 here. 10 times x is 10x. 2x times 2 is 4x. Will 10 and 4 add to a 3? No. 10 minus 4 is 6. 10 plus 4 is 14. I'm all done with 10 and 2. I didn't see anything that's going to work. All right, now I'm going to move on to 4 and 5. 4 and 5. 4 times x is 4x. 2x times 5 is 10x. And then 4 is not going to add to 3, so I switch my numbers. 5 over here. 4 over here. And now we're looking at 5 times x is 5x. 2x times 4 is 8x. Can I get an 8x and a 5x to add to a 3? Yes. I would have to subtract. I need a positive 3. 8 minus 5 would give me a negative 3x. That means I need a negative 5x and a positive 8x. That is less than or equal to 0. We're ready to solve these. We have 2x minus 5 equals 0, and x plus 4 equals 0. Here, we're going to shift the 5 over. 2x equals 5, so x equals 5 halves. And we have x equals negative 4. How can I do this algebraically? Well, I know that the parabola is facing upwards. So I have this parabola. Let's put our stuff on the number line first. What do we have? We have negative 4. 1, 2, 3, 4. And we have 5 halves. 1, 2, 3. We have this parabola. It's positive. That means it's facing upwards. It would have to be, so this is 2x squared. It would have to be a negative 2x squared to be facing downwards. Okay, we know it's this one. It's facing upwards. So I have this parabola. It's facing upwards. I can check this by checking values. I would need to check a value over here, a value in between, and a value over here. You're checking. Let's pick negative 5. I'm going to check negative 5. All right. Negative 5. I'm going to check negative 5. We have 2 times negative 5 squared plus 3 times negative 5 minus 20. Is that less than or equal to 0? 25 times 2 is 50 minus 15 minus 20. Is that less than 0? Negative 35. Is 15 less than or equal to 0? No. So the solution could not be over here. Let's check a number in between here now. I'm going to check 0. Two times 0 squared plus 3 times 0 minus 20. Is that less than or equal to 0? 0 squared is 0 times 2 is 0. 0 minus 20. Is that less than or equal to 0? Is negative 20 less than or equal to 0? Check. That's a true solution. That means that my solutions would have to be inside of here. They couldn't be on the outside. The solutions would be between these two numbers. Well, where is the parabola between these two numbers? That would be here. This is between these two numbers. My solution would be then that it is equal to, so it's greater than or equal to 4 and less than or equal to 5/2. It would be greater than -4 and less than 5/2, and it includes both those numbers. Interval notation, final answer. That's how to check it algebraically. You just sketch your graph, you've got your intercepts, you're checking something over here for a true statement, or in here, this would also be false over here. Either it's going to be on the outside, going to infinity, or would be in between them. We found that this was a true solution in between. Solve x squared minus 4x plus 1. It does say to solve it graphically. X squared minus 4x plus 1 graph. All right, solve this graphically. Well, we want to find those intercepts. We need to calculate these x-intercepts. Again, we're going to go to second calculate, but this time, instead of intersection, we're looking for 0. Zeros means the x-intercept. Second, calculate number 2. It's going to ask for a left bound and right bound. Here's the intercept. When am I on the left-hand side of it? When I'm on top or when I'm on the bottom? This is where I'd be on the left-hand side. So I need to be on top. That's my left bound. When I'm on bottom of the x-intercept, that is when I'm on the right-hand side. And we get 0.267, so 0.27. Now we're going to calculate the second one. Calculates. Number 2, another 0. And we're going to go over to the other 0 here. It's asking for a left bound. This is where I'm on the left-hand side of the intercept. Enter. There's my arrow that shows that's where I'm starting. And then I go on the right, enter, enter again, and I see 3.73. We go back to the original question. When is the parabola greater than or equal to 0? And it went down to about -3. 1, 2, 3. Sketch the parabola. All right, now I'm ready to answer the question. When is the parabola greater than or equal to 0? That would be when y equals 0. This is where y equals 0. When is the parabola greater than or equal to 0? The parabola is greater than 0 when it's above y equals 0. That is where it is greater than 0. And it says greater than or equal to. So at these points, it could be there or greater than. We can answer the final question. So from -infinity to 2.7. -infinity all the way up to 2.27, 2700ths. Does not include -infinity, but it does include 2700ths. In union, it's going to start at 3.73. It does include 3.73, and it's going to go to infinity. Final answer. Example 6, solve graphically. X squared plus 2x plus 2. Graph. I'm going to go to my standard zoom, number 6. That is above the axis. All right. When is the parabola less than 0? Here's y equals 0. What is your answer? When is the parabola less than 0? Here's 0. Is it less than 0? No solution. It's not less than 0. There's nothing down here. There's no solution. Example 7. Solve x cubed plus 2x squared minus 1 is greater than or equal to 0 graphically. X, here's to make to the third power right here, the little hi-hat, to the third power, arrow over, plus 2x squared minus 1. All right, this shape definitely looks different. We need to solve this. When is it greater than or equal to 0? Let's zoom in a little bit on this. Zoom in, number 2. There is a tiny little cursor right there that's blinking, and that's where I want it to be, in the middle of the function. Enter. All right. Here is the shape. With degree 3 is coming. Let's calculate those zeros. We're going to go to calculate. So second, calculate number 2. All right, we want to be on the left-hand side of this. That would be down on bottom. Enter. Now we want to be on top, where we'll be on the right-hand side of it. Enter. There's my 2 arrows. It's looking between there. Enter again. Negative 1.6. So we have x equals negative 1.6. We have 2 more. So that's a total of 1, 2, 3. A degree 3 has 3 solutions. There's 1. We're going to calculate another 0, number 2. Move over. Here on the left-hand side, I'd be on top. Enter. The right-hand side, I'd be on bottom. Enter. Enter again. We get negative 1. And the last one, calculate. 0. Left bound. On the left, enter. And right bound, I'm on the right. 0.62. Or 0.6. Looking at the graph. When is the cubic greater than or equal to 0? When is it greater than or equal to 0? That would be between these 2 numbers. So it's greater than y equals 0. And then at this point, that is greater than 0. All right. We're going from negative 1.6 to negative 1. Does include those numbers. Negative 1.6 to negative 1. In union from 0.6 to infinity. And it does not include infinity. Projectile motion. These are one of my favorites. Projectile motions. It's also called particles motion. Now you're starting to see things move. We've been at a standstill most of the time. The movement of an object that is propelled vertically, then subject only to the force of gravity. Projectile motion. Suppose an object is launched vertically from a point s of 0 feet above the ground with initial velocity of v to 0 feet per second. The vertical position s in feet of the object t seconds after it is launched is S equals negative 16t squared plus v of t plus s of 0. All right. We know that launched vertically from a point is, the launching point is s of 0. Initial velocity, feet per second, is v of 0 and t seconds. All right, so we have t, seconds, velocity, and the starting point. A projectile is launched straight up from the ground level with an initial velocity of 288. We know that it's launched straight up where? From the ground level. That means that s of 0 would be 0, and the initial velocity is 288. V of 0 equals 288, and that would be feet per second. That is the information that we have. So s of 0, the initial launching point is 0. The velocity is 288 feet per second. The vertical position equals negative 16t squared plus the velocity t plus the launching point. We're going to substitute in our values. Velocity is 288, and the launching point is from the ground at 0. We're going to graph s equals negative 16t squared plus 288t. Let's graph that. When will the projectile's height above the ground be 1,152 feet? The vertical position. When will the vertical position be 1152? Put everything on the same side. Let's move our t squared to the left, so it'll be positive. So we have 16 t squared minus 288 t plus 1152 equals 0. So we just shifted our terms to the other side. Let's see if we can reduce this down at all. Try getting t squared by itself. Are these divisible by 16? 288 divided by 16 is 18t. 1152 divided by 16 is 72. And 0 divided by 16 is 0. Does this factors of 72 that will add to 18? We know 1 and 72, no. What do we have for factors of 72? 2 and 36. 3 and 72 divided by 3 is 24. Adding to 18, we're getting there. 72 divided by 4. 4 and 18. 5, 6 works. 6 and 12 is 18. 6 and 12 is 18. Have to be negative, negative. 8 and 9 also equals 17. So 6 and 12, they would have to be both negative. Negative 6, negative 12, add to negative 18, and negative 6 times negative 12 multiplies to a positive 72. So they add to negative 18, but they multiply to positive 72. All right, there we go. We have t, and then we have minus 6, minus 12. And when we solve these, we get that t equals 6, t equals 12. So the projectile is above the ground twice, once at 6 seconds. All right, let's take a look at this. The original is right here. I need to graph this one. The x, we do not need to go up to 500. What are our x's? 12. Let's just go to 20 and go by 2's. There we go. We want to know when it equals this. This is the piece I want to graph right here. Let's also put in that y equals 1152. Yeah. When will the projectile's height above ground be 1152? When will it be that? It will be that at these two places. Twice. Once on the way up and once on the way down. So the answer to this one would be t equals 6 seconds. T equals 12 seconds. When will the projectile's height above the ground be at the very least, 1152? That would be starting here and all the way to here. That's at least 1152. We're between 6 and 12. That includes 6 and that includes 12. This graph, we have it up and down again. This would be y equals 1152. So problem B, at least 1152. That would be from here to here. At the very least, and then it can be anything above that. So we would say that it has to be between 6 and 12. It includes 6 and it includes 12. It would be 6